Okay, so let's move on. This is how a tube works, and all you guitar players that play tube amps, you know what that sounds like as opposed to a transistor. So how does a transistor work with this basic principle? Now, this was started in 1906 is when they started with tubes. But transistors look like this. The one on the left, the 2N3055, is a power transistor. And then these are other transistors, and they get pretty hot. So the metal casing here has two bolt spots on it, and it's usually bolted to a big piece of metal with fins on it so that air can cool it. It's called a heat sink. So it takes the heat that's generated inside of this little device and it sort of radiates it so it doesn't overheat and blow up. Same thing with this one, except there's a hole in the center. It gets bolted down to a heat sink. And actually on one side you put heat conducting material so that the heat can exit the transistor and go into this piece of metal where the air flow can cool it. And then they get smaller and smaller. When was the transistor invented? It was invented in 1947. These three guys, Bardeen, Shockley, and Breton, at the Bell Labs. There you go, telephones again. Telephones has been very instrumental in audio development because their whole livelihood depends on how to get a voice across a wire to another person. Okay, so they were working with new ideas. How can we do this? Because transistors would be much smaller, much lighter, use much less energy because you don't need this filament to heat them up, and high voltage inside of a tube to get these electrons to start moving off one plate to go to the next. And so what ends up happening is they come up with this idea. The idea is, let's take an element that actually has a very small amount of shells. So it has a nucleus, and in the first shell it would have 1 electron, 2 electrons. The next shell can hold up to 8, except they chose an element that only had 4 in its outer shell. And the way that elements work is that to be more stable, they either want to give up these electrons in their outer shell, it means send them off to another atom, or take on 4 more so it has a full shell of 8, because it likes to have stability, having each shell full. So that means that this type of element can either give off electrons or take on electrons. It doesn't matter, it likes either way. It's more than happy to do that. Now, if this only had 3 electrons in its outer shell, it would want to give them off. It doesn't want to get 5, it wants to give off those 3. So they chose this because of its property of being able to take on electrons or give them. So this element right here is actually carbon, if I remember my periodic table. Okay, so carbon actually has 6 electrons, 4 in the outer shell, 2 in the inner shell. And why is it that carbon is so instrumental to building compounds? Because of this property. Human life is built on carbon. You've heard everywhere carbon-based life. That's what it is. Because of carbon being able to combine with a multitude of elements, create multiple different kinds of compounds. Now, what they chose to use first was germanium. It's a much bigger atom because they were still thinking, well, we need a lot of instability so it can give up electrons or take on. And so we couldn't use carbon. We need to use germanium. And then later on, once they started working out how to do this in solid state, they ended up using silicon. Silicon has, I think, another shell, like 8, and then the next shell is half full, I believe. Silicon is sand, right? Majority of the element in sand is silicon. Now, the interesting thing about it is, and this is just me being like science fiction, is that, since life is based on carbon, couldn't life be based on silicon just as easily? Because it has the same basic properties of giving off or taking on electrons. It probably could be. Not human life, maybe, but alien life. Anyway, so they ended up deciding that they were going to make what's called a germanium first, and then later on a silicon transistor. And what they did is they took the whole concept of a tube, where you've got a power source, an output, and an input that modulates the power source, and they basically doped different regions with different kinds of elements. So they start out with pure silicon, which is actually extremely expensive. You've seen those films, I'm sure, where these guys are working in the clean rooms, making transistors or integrated circuits, or actually your computer microprocessor is one little piece of silicon. And what they do is they inject different elements into different parts of it to give it different electrical properties. So the NPN and the PNP regions, they dope it with an element with one extra electron, 5 in the outer shell instead of 4, or they dope it with an element that has 3 electrons in the outer shell, so it wants to give them off, and the one with 5 wants to take them on. So that's kind of how they change the electrical properties of the silicon in different regions to have different kinds of controls over it. So the voltage difference create electron mobility between the doped regions, which is very similar to how we tried to get electrons to move from one plate to the next through a screen. And doping is done with heating and pressure with different elements, and this is why they need a clean room, because pure silicon, if you're doping it with another element, they use a variety of elements to dope into these transistor or pure silicon chips. And if there's any impurities in the room, it can be injected into the silicon and totally mess up the whole electrical characteristic. But they can actually, on one piece of silicon, create resistors, capacitors, diodes, the things we've been talking about. They can create all of those on one little chip. And they use photographic processes where they take a photograph and shrink it down of the circuitry, shrink it down, and use that to put a resist layer on the silicon. So when they dope in different elements, it only goes into certain spots. Sort of like if you've ever seen a screen print where the first screen goes down, they put color over it, then they take that off, put a second screen down that has different spots open, put a different color down, and they build their picture that way. When they're done with all the screens, it's a multicolored picture in different areas, different colors, and so on. So that's how they do it. It's a fairly complicated process, and that's why it took so long to develop. So instead of using cathode, anode, and grid or screen, they use base, collector, and emitter. Emitter emits electrons, collector collects electrons, base controls the electron flow. And there's a bunch of different types. Right? It's basically the same concept. It's just now we're talking about solid state. So you can't break it by dropping it. It doesn't get as hot, takes up much less space. In fact, it's great to go into space. Space program used these a lot. That's the only reason we could go into space. If you tried to bring a computer built out of tubes, it would be the size of this room. Let's look at some of the positive and negative qualities. Tubes use high voltage, large size, delicate, generate a lot of heat from the filament, and fail over time. Because of that heat that's generated, it'll eventually break down and not work. Where transistors use low voltage, small sizes, very durable, very reliable. You can drop them, they're fine. They run cool except from excessive heat current flow, which is in the power transistors on the output stage of a big amplifier. But then you can dissipate that heat fairly easily. Both tube and transistors operate on the same principle. You can just think of that water spigot, that's how they work. Now, for the people that actually aren't guitar players and don't use guitar amps, tubes, or transistors, how would you describe it? The tube is warmer than the transistor, so the transistor is cleaner maybe, and that actually arises from any little distortions in the amplification process. The tube sort of amplifies different harmonics in the structure of the sound than the transistor, and so that's why they sound a little different, but they both have pleasing sounds. I mean, some amplifiers use tubes on the preamp and transistors on the output because of the heat generation process and the reliability. So you can use a combination of both too, which is sort of my favorite sound. It's pretty impressive, isn't it? I mean, the technology is really impressive. From 1947, inventing the transistor, to now.